this month's API Security Workshop, special edition for October Cybersecurity Awareness Month. Thanks for joining. Let us know where you're joining. Hopefully, you can jump in Hey, Claudio, you're first. Thank you for letting me know some of you are out there. Really nice to have you all here with me for another session here. If you've attended one of my workshops in the past, this is going to be pretty repetitive. We do have some special announcements and fun stuff at the end, but if you're looking for some new stuff, this will be kind of what we did last month and the month before, always a few little tweaks and adjustments. But hey, everyone, what do I see? Quebec, Germany, Philippines, Colombia, Columbus, Ohio. I love Columbus, even though I'm a Wolverine, but don't tell anyone. But anyways, thanks for joining us here today. As always, for these workshops. Oh man, Juan Pablo from Chile. That's my father's country. Really nice to see you, Madagascar, India. Wow, this is a super international audience. As always, we want to thank you for being here. If you'd like to get a certificate of attendance, get some CPE credits for having attended this session, we'll put up a link at the end of the session. You can apply. You can get your Credly badge and certificate. Put it on your LinkedIn. Hopefully, say some nice things about the event as well. As always, the way we do these workshops, there are 3 sections. First section is why are APIs under attack? Section 2 is let's go through some real world examples and really, crystallize this, make it very real for you what the risks are. And we're going to map some of those real world breaches to the OWASP top 10. So you learn about the OWASP as well. And in the third section, we'll go through what are some best practices, some things you can do to better protect your APIs. As always, we welcome questions along the way. My colleague, Shelby, is behind the scenes, keeping everything running smoothly. I'm sure you've seen her name around. So if you got questions, throw them in there. I'll do my best to keep an eye on those, and we can answer them as we go along, right? And one thing to keep in mind is this workshop that we do every month publicly, we also do them privately, right? So if you've got an organization that could benefit from getting more awareness on API risks and all the things that we talk about here, let us know. Reach out to me or Shelby. And in fact, thank you very much. Right on cue, Shelby's got the link there. You can request a private workshop for your organization. We can't do all of them, but we certainly try our best. There's no cost. It's all free. And we certainly love to spread the word about APIs and how to make them more secure in the world. So let's go ahead and dive right in. If you're not familiar with APIsec U, I'm sure the vast majority of you are. We're actually over 90,000 students. I got to update this slide. And all of these wonderful courses, all free. We are right about, and a lot of you have been waiting a long time. We're about to launch the AI course, AI security course. It's done. It's loaded. We just got to put some finishing touches on it. So it is coming finally. I know I've been waiting all year for that, so it is ready to go. All right, let's go ahead and get started. All right, why are APIs under attack? I always like to start with these 3 stats. It kind of conveys the situation in the market. 83%. What is that? That is the percent of the internet's traffic that is API powered. This is a stat from Akamai from a few years ago. Really astounding, right? 83% of all internet traffic is enabled by API calls, right? Whenever you log into your bank account, look for a nearest branch, deposit a check, transfer money, those are all API calls going on behind the scenes, right? So this really reflects the explosion in adoption of APIs as a really enabling technology for how we build and run our applications. And it's wonderful technology. Number 1, though, is where API attacks rank, according to Gartner. They were predicting that by 2022, API attacks would be the number 1 most frequent attack vector. I don't know about most frequent, but certainly most successful. And you'll see that here in a moment. And 4% kind of reflects the state of API security, which is not good, right? This is a survey done by Rapid API. They have millions of users. 96% of the testing, according to their community, is positive testing, right? Looking for bugs, making sure it works, performs, integrates, all of that stuff. Way down at 4%. Respondents saying they do security testing on their APIs. That's way too low. There's reason why that number is so low, and we'll dig into it. Okay, but why APIs? Like, why are APIs under attack? What's so special about them? It's a very simple graphic. I'm a simple guy. I need simple diagrams to explain things. Just look at where APIs sit, right? It is the connective tissue, the plumbing, it's what makes the internet work, right? So when I log into my bank account through that web interface or that mobile app, it's making an API call that's going right through all the firewalls and detection systems and so forth, straight to that backend where the data sits, the transactions, the functionality, the logic, right? APIs are sitting right in here, connecting the front end to the back end, right? And if there are any flaws in how those APIs are configured, how they're set up, the logic behind them, the rules, then that can turn into vulnerabilities, that can turn into exploits. Okay, so that's why APIs. And yes, I guess we can go ahead and Shelby, can you pull down the workshop thing? It looks like it's blocking some people. So all right, so that's that. And the last bullet here you see can be easily discovered. There are lots of breach examples where I just assume these organizations figured APIs were hidden and not going to be found. And in fact, it's incredibly easy to find these APIs. And let me just show you, right? What you see here is I'm looking up some flights on United.com. I'm not picking on United. This is how every website works pretty much. If I want to find the APIs here, all I got to do in my browser, I don't have to install anything fancy, is right click, hit the inspect button, go to the network tab, search for APIs. And right there in that red box, you can see the fetch flights API call, right? It's a post method. If I actually look at the payload, I could see the actual construction of the request, right? This is what attackers are looking for, right? And so these aren't hidden. These are right out there in plain sight for any minimally savvy attacker, right? So don't assume your APIs are hidden and not going to be found. It's actually incredibly easy to find. And let me show you how virtually every API attack happens, right? What happens? Your attackers that come to your site, your homepage, they install your mobile app, and they use every feature and function of the application, right? And they watch the traffic going on between their browser and your backend, and they identify all those API calls that are going on, just like I just showed you. And the next thing they do is go around your UI and hit the API directly, right? And if you think about it, the UI is a very controlled environment, right? I can only see the data you show me. I can only press the buttons that you present to me. It's very locked down. But your API is very uncontrolled. And what I mean by that is it's just a command line. And I can write any request that I want and send it, right? It's nothing's going to stop me. And now we're relying on that back end to know whether that's a legitimate request, a malicious request, or anything else, right? And you'll see an example here in a moment of exactly that happening, right? And what attackers are looking for and what they often find at that API layer are APIs that are over permissioned, right? They have access to all kinds of features and functions and data that you might not want the end user to be able to access, right? And it exposes logic flaws, right? The UI is a great band-aid for missing controls in the back end, but when your attackers bypass your UI, they bypass all those controls as well, right? And this is the number one reason why APIs are such a ripe target for attackers, right? Let me see here. Wolfram. My opinion, even those backend calls of those old Java apps can be called API. Yeah, indeed, right? The concept of APIs have been around for decades now. It's just sort of been standardized on REST and Graph and so forth. Okay. Regulators are paying a lot of attention to this now. So if you're transacting credit cards, if you've got PII information, you're covered under GDPR and other privacy initiatives. HIPAA for healthcare. If you're a publicly traded company here in the States, you've got the SEC 4-day breach notification requirements. Automotive vendors and suppliers, you've got a United Nations regulation, FedRAMP for the government. APIs are very much on the radar for your auditors. And in fact, let me give you an example here. This is from about a month ago. The Federal Communications Commissions, they're the body that regulate the telcos here in the US. TracFone is actually owned by Verizon. They completed an investigation and determined that subscriber data had been leaked through a TracFone API. This resulted in a $16 million fine to TracFone/Verizon. And beyond that, the FCC mandated a bunch of technical and people process requirements, right? Education and things like that. But also, you see it here in yellow, TracFone must perform continuous static and dynamic testing, prioritizing APIs with automated tools to look for vulnerabilities, right? This is going to be a key theme for the session today, right? The need to test and find vulnerabilities in our APIs before they ever go live, right? And this is one of the best things that we can do to secure our APIs better. Okay. Ranjit, yes, we do record these sessions. And in fact, you can already find last month's session over on our YouTube channel. So please like and subscribe. Okay. So that's the why API security, right? Why are APIs under attack? So let's go into what's happening in the real world. And what's happening in the real world is a boatload of API attacks and successful ones and exploits and breaches and so forth. This is just a sampling of high profile attacks that we could find from our research. What jumps out to me is just the sheer volume of examples out there. Every one of these is an API breach, API attack, right? And look at the number of records, 10 million, 100 million. The entire LinkedIn database, 700 million records harvested through a leaky API, right? And these are really sophisticated companies on this page, right? So it's not like they didn't have, the best technologies, the most, trained and expertise personnel and so forth. And so there is something about API attacks that are getting through the defenses, right? I guarantee you everyone on this slide had WAF in place, SIM, other detection. They were doing static code analysis, dynamic testing, pen testing, all of these things, and still they got breached, right? So we're going to expand on that. And what we're going to do is we're going to unpack a few examples, and we're going to map those to the OWASP top 10. Right. I imagine most of you are familiar with OWASP. It's the Open Worldwide Application Security Project. It's a nonprofit. They really do fabulous work. In 2019, they issued a top 10 dedicated to APIs, right? Recognizing that API threats and API attacks are different than what we see on our websites and our web apps. And in 2023, they updated that. So that's what you see here. And if you want to go deep on this, I highly recommend you check out our OWASP course. Corey is the instructor on it. It's really fantastic. We have a certification and an exam called Kasa, Certified API Security Analyst exam. This is a paid exam, but at the end of this call, on this workshop, I'm going to give you an opportunity to get that Kasa exam for free. So just stick around to the end and you'll see how to do that. But let's go ahead and tell some stories, right? So the first example is from Coinbase, and I'm going to show you how you can make 4,000% return in one API call, okay? So Coinbase is a crypto platform. If you want to buy and sell Bitcoin, here's where you do it. And here there was a hacker researcher who wanted to poke around the Coinbase platform and see if they could find any flaws or vulnerabilities or issues in the API. And like a good hacker, went to the homepage, created an account, deposited some money, started trading, utilizing every feature and function of the app, and watched all that traffic going between their browser and the back end. And what you see here is, thank you, Wolfram. Appreciate that. What you see here is what the traffic looks like when you do a trade, right? So in yellow, you see the base size, that's the quantity. You see the price, you see the product ID, right? In this case, he's selling Ethereum on the European market. and then a source account and a target account. Okay, this is a valid request. He owned Ethereum in that quantity and so forth. But one of the things attackers like to do is send intentionally erroneous requests in order to see what kind of error messages come back. Because sometimes we reveal useful information in our error messages, like, email is required, or, what type of tech stack is running and so forth. Excuse me. One sec. Talking too fast here. All right. Andres, does the course contain, I'll let Wolfram answer your question, Andres. So he wanted to get an error message. So he backspaced over the Ethereum, which he owned, and he wrote Bitcoin, which he did not own. Okay. Hit submit, waited for the error message to come back. And what came back was not an error message, but a trade confirmation. And you can see here that his $1,060 of Ethereum sold as $43,000 of Bitcoin. And it actually worked. Right. And I think this guy must have thought he was going to prison. Immediately went on the Twitter and said, can I get a direct line with someone at Coinbase, maybe the CEO, because this is potentially market nuking. And that is not an exaggeration. And Coinbase gets a lot of credit. They immediately shut down the market for 24 hours. They reproduced the issue, fixed the issue. And a week later, they blogged and explained what happened. And what happened was the underlying cause of the bug was a missing logic validation check, right? And what that means is the app was checking, does this person have 0.024 units? Yes. And it went ahead and processed the trade. It was not checking what he owned. And that's the logic gap here. And if you think about this, there's no way you could perform this exploit in the UI, right? This is an example of a logic flaw that's exploitable at the API layer, not at the UI. There's no button in the UI to turn your Ethereum into Bitcoin, right? And this is what attackers are looking for in your APIs. Okay, so that's our first example. The next example is from Peloton. Here was another researcher poked around Peloton. They found all these API calls. Many of them were unsecured, meaning no password, no credentials required. And one of these API calls, thanks, Ken. It's a remarkable example. One of these API calls had access to the entire Peloton user database. Even if you marked your account as private, like you don't want to, friend anybody, even your records were exposed, even Joe Biden's, right? So they notified Peloton, said, hey, you're leaking a bunch of information on this unsecured API endpoint. Eventually, Peloton fixed the issue. And what did they do? They locked down the API. And they said, all right, we're going to require authentication to access this endpoint. But here's the problem. Anybody can go create an account on Peloton. They can use those credentials. They can access this API endpoint, and you still could access 4 million users' records, right? So they addressed one issue, which is authentication, right? The door was left unlocked, but they didn't address the other issue, which is authorization, right? Can Dan access Shelby's records, for example, right? So that's these are both good examples of OWASP number one, BOLA, broken object level authorization. Classic example is, can user A access user B's data, which is what we see here at Peloton or at Coinbase. Can I trade on an object I don't own, right? That's an example of an authorization flaw. Okay. All right. So let's go on to number two. And the example here is Duolingo. So imagine we have some Duolingo users here. I myself am a Duolingo user. 2.5 million records leaked. There was an API, it was discovered, no authentication on it. And if you submitted an email to that endpoint, it would respond back with, is this an active Duolingo user? And everything about that user, right? So, so I went, when this got announced or discovered, I went and I hacked myself. And this is what happened. I'm not very technical, as you all know. I didn't even have to go to a command line and do anything fancy. You could even do it from a browser. All you had to do is go to that URL, put email equals your email, and immediately you get all this information. No challenge. So I could have put my email address as I did here, or your email, or my next door neighbors, or anybody's, and I would be able to collect all this information about them, right? So why would you leave an API like this open? Well, I have a theory on this, which is number one, there's a myth, a misperception that APIs are hidden and undiscoverable, which obviously that's not true. And the other is we have a lot of pressure on developers to push out code, hit due dates, fix bugs, add features, and all of these things that sales and the business is demanding, right? And we don't always have time to sit there and think about every security issue, right? So assume your APIs will be discovered; they're not hidden. And this is a good example of OWASP number 2, which is broken authentication, right? Defined as weak or poor authentication, like no CAPTCHA, no two-factor credential stuffing, which you should implement the best, most appropriate authentication. But what you will see here in all these examples is I'm not even talking about that. These are examples of no authentication, right? We saw it at Peloton, right? Those APIs were left unsecured. You're seeing it here at Duolingo. You'll see more as well. Okay. All right. Samra, do you guys use Postman for testing APIs? Samra, I really want you to stick around to the very end of this call because we're gonna announce some cool stuff. And we have a session next week that I think you'll be interested in as well. Okay. So next example is Venmo. This is for OWASP 3. So Venmo payment platform. Here there was an attacker. They poked around this the Venmo site, and on the homepage of Venmo, they had a feature that showed the last 10 or 20 transactions in real time, right? But it was anonymized data, right? So it might have my first name, but no last name or account details, and so forth, right? So so here this attacker found the API that was powering that homepage feature, right? It was a public API, no authorization required, right? But here's the key. When they queried the API directly, it did not return anonymized data. It returned the whole record, every field, every feature of that API. So they went ahead and wrote a script, and they probably took months to do this and harvested over 200 million transactions off Venmo in complete detail, right? So what's the pro tip here? Do not filter data in the UI, right? We've been talking about how UI is not part of your security stack, it's presentation. It should have made a special API that only returned the minimum amount of information and nothing more, right? And this is what OWASP 3, broken object property level authorization, is all about. That's kind of a mouthful, BOPLA. They used to call this excess data exposure, right? And that's what's happening here, right? We have an API returning way too much information for the business use case, right? Parth, stick around. I want to show you some testing capabilities that we're launching here as well. So, all right, that's number 3. For number 4, we got Trello. This is from earlier this year in January. Can't believe we're already in October. It's incredible. So on Trello, if I wanted to invite you to my Trello board, there's a feature for that, right? I give them your email address, and some backend process will send you an invitation to my Trello board. Well, that backend process is powered by an API. That API was also left exposed and public with no credentials, no security on it. And if you supply an email to that endpoint, it'll respond to you and say, is this an existing Trello user? And all this detail about that user, right? When this attacker found that endpoint, they knew they had hit a gold mine. And what they did was they went onto the dark web. They harvested 500 million email addresses from other breaches, right? And they sent 500 million requests at this API endpoint looking for matches. And they found 15 million, as you can see here in the yellow box, right? And it had email address, username, full name, account details, all kinds of stuff, right? And they took that 15 million, put it on the dark web up for sale, right? So this is an example of OWASP 4, unrestricted resource consumption. Here, 500 million requests got submitted without being blocked or detected or somehow defeated, right? And so you might conclude that they needed to implement WAF or rate limiting. They were doing all of that, right? So so what do you do about this, right? Why was this successful? Well, attackers are clever and they're patient, right? So they know you've got rate limiting in place, right? So they probably ratcheted up their requests until they got blocked, And then they dialed it back by 10%, and they can leave it there for months and distribute across thousands of IPs and use residential proxies and all this kind of stuff, right? So a determined attacker is going to find a way around your rate limiting protections, right? You should employ rate limiting, but don't expect it to be a silver bullet, okay? So what did they do about this, right? Trello, they're owned by Atlassian. What did they do? They made a change so that unauthenticated users could not use this API, right? I.e., you have to authenticate to this endpoint if you're going to use it. And the reason why that was an effective response is it's a whole lot easier to identify abuse of 500 million requests coming from Dan than 500 million anonymous requests, right? So simply by locking down that API, they could prevent that kind of abuse in the future. Cool. Thank you, Kevin. Appreciate the chat or the comment about our new tool. Can't wait to give you a sneak peek here. All right, 2 more examples, and then we'll move forward. So for OWASP 5, the example here is Bumble, dating site, over 100 million users. They got a lot of things wrong here: unsecured endpoints, BOLA issues, data exposure. But what makes this OWASP 5, which is broken function level authorization, is they not only exposed data that the end user shouldn't see, right? Like my records, your records, and so forth, but they also exposed or gave access to functions that the end user shouldn't be able to execute. Specifically, the ability to change your account type, right? So in Bumble, they have a free account, they have a paid account, right? And there's an API to check what kind of account you've got. That's called a GET request, right? So that's just a lookup. Tell me what kind of account I have. Am I free, paid, premium, whatever, right? But they also expose the post method on that endpoint, which means not only could I look it up, I could also change it, right? And I could just send this API call and say, change my account from free to paid. And it would work. And suddenly you're a paid user as far as they know, right? That's a function that should never have been available to the end user. It was, and this attacker was able to change their records or anybody's records from free to paid, right? And that's broken function level authorization. Okay. And my last example here, and by Robinson, rate limiting is good, but don't rely on IP based. Yeah, indeed. Great comment. All right, last example I want to share with you. It's a really important one because it introduces business logic into the discussion. So for Instagram, they had a feature on the homepage that allowed you to reset your password. So say you wanted to take over Taylor Swift's account. Here's what you do. You go to Instagram, you pretend to be Taylor Swift, and you say, I forgot my password. And it would send a 6-digit code to the real Taylor Swift, which you would not get, right? But it turns out there's an API that you can use to submit your guess. Well, 6 digits, that's a million combinations. So all I got to do is start at 1 and iterate until I get to the right request, somewhere before a million, right? But there were some restrictions and constraints, right? So there was a 10-minute timeout on that code, but that's plenty of time to do a million API calls, as we know, right? And they also had a 200 guess limit, right? So this person tried 200 times, they got blocked, and they thought they were kind of done. But they tried one last thing. They rotated their IP address, and surprisingly, they got 200 new guesses. So they just keep rotating their IPs every 200 and keep doing that, parallelize it, and easily get through all million combinations within the 10 minutes, right? So this is an example of OWASP 6, unrestricted access to sensitive business flows, right? And the sort of takeaway here is we need to think not just about how our business flows are meant to work, right? We tend to think about like, does the product work as designed? And in this case, it did, right? If I forgot my password, there's a perfectly good process to reset my password, right? But the way they implemented it created its own vulnerability, its own exploit, right? I could brute force that logic in order to take over anybody's account. So we need to think not just about the positive flow, the happy path, but also how could that logic be abused and misused and exploited, right? And in the case here of Instagram, there are lots of things they could have done differently. Number one, 200, or number one, IP address is irrelevant. Should never been part of the equation. Number two, 200 guesses is probably way too many, right? 4 or 5, and then expire the code. It's no longer valid. And number three, don't use an incremental reset code, right? By making it a numerical code, you're basically saying, hey, attackers, the code is somewhere between 1 and a million. Good luck, right? If they made it alphanumeric, it's impossible now, right? It's not a million combinations, it's a billion, right? And you're just not going to even try at that point, right? So very important to think not just about how our apps are meant to work, but how are they not meant to work. So that's it for my examples. For the rest, in the interest of time, I'm going to skim through the rest of the top 10 here. Number 7 is server-side request forgery. So this is really all about tricking your API server into going somewhere it shouldn't. So for example, if you ask the users to provide their LinkedIn profile URL, and instead of giving you something that starts with www.linkedin, they give you something that's actually a malware site, or /localhost etc password or whatever, right? If it doesn't look like a LinkedIn URL, throw it away, right? Do your input validation. If it doesn't look right, throw it away, block that user, but don't process it, right? Number 8 is security misconfiguration. This is really the kitchen sink of standard good API best practices in hygiene. So encryption and patching and hardening and turning off services and using rate limiting and not revealing useful error messages, all that kind of stuff, right? Number 9, excuse me, number 9 is improper inventory management. This is really all about knowing your API ecosystem. What APIs do we have? What are they? Where are they running? Who created them? Have they been tested? Are they in our gateway? All of this stuff. You got to know your API inventory. And 10 is unsafe consumption, which is really kind of the reverse, which is what are those APIs that we are using from third parties? Right? Are we using Salesforce APIs, DocuSign, Venmo, you name it, right? Don't assume they're safe or implemented properly just because it came from a third party, right? So do your same input validation, do your testing, your authorization checks, all that kind of stuff for your third party APIs as well. Okay. Looks like there's a really good conversation going on here. So apologize if I'm missing some good questions in there, but we'll try to get to them. All right. So that is the what's happening in the real world. I threw a lot of info at you. We went through all of the top 10, a bunch of examples, and hopefully you're seeing that API threats are real, right? And the attacks are not theoretical. They're happening. They're succeeding. The OWASP top 10 is a really great guide to get you focused on the right types of things that are actually causing the breaches out there. So let's talk about how we can secure our APIs. And the first thing we wanted to do was analyze all those breaches I showed you before and see if there were any kind of patterns or commonalities or, typical attack vectors. And in fact, there were. So we analyzed all these and we kind of categorized all the attacks. And what you see here is that the top 4 are really dominating how APIs are getting attacked, right? And right at the top of the list is rate limiting, right? OWASP number, was that number 4, I think. Unrestricted resource consumption, right? And so, excuse me, you might conclude that this is the number one thing for you to fix, right? We need better rate limiting. But really, this is probably the wrong conclusion, right? What you should take away from this is rate limiting is not a perfect defense, right? A determined attacker is going to find a way around your rate limiting, right? We've talked about how they'll go about doing it. And at the end of the day, this is not a root cause, right? The root cause is you've got APIs revealing something of value, right? It's making the attacker want to brute force your API, right? But this is not the rate limiting challenge is not the root cause, right? It's just simply making the root cause worse, right? It's not blocking those attacks, right? So if it's not the root cause, then what is? And it turns out the next 3 items, which non-coincidentally map to OWASP 1, 2, and 3, were responsible for 90% of the breaches on that last slide. This was extremely eye-opening when we ran this analysis, right? What that suggests is if we can address OWASP 1, 2, and 3, we've made a huge dent in our API exposure, right? I've done these workshops for engineering teams where I've had people chime in at the end and say, I already know code I got to fix, right? And what are we talking about, right? OWASP 1, broken authorization. Can user A access user B, right? So let's make sure when we're developing our APIs that we're thinking about those authorization rules and making sure they're coded very well and tightly to prevent that kind of cross-account contamination, right? OWASP 2, broken authentication, right? I'm not even talking about complex authentication. I'm talking about like make sure you're locking the door on your API with any authentication. And of course, you really want to dial up or down your authentication to the use case, right? If you're transacting goods or your banking app and so forth, you want to make sure you have the right level of authentication on your applications. We actually have a fantastic course on our site called API authentication, and it's taught by our good friend Jakob at Curity. Really great course if you want to learn all about API authentication. And then OWASP 3, excess data exposure, right? Like think about that Venmo example where it was returning the whole record, right? So make sure we're not revealing or delivering back to users more info than is required, right? So if you could address these three things effectively, you put a huge dent in protecting your API security, right? This is why we recommend that developers participate in these workshops as well, right? So let's move on to what can we do to better secure our API. So here's a very simple kind of life cycle of an API. And we looked at like what are the types of things you can do to implement security through the life cycle, right? On the far left, right, API definition or the design phase. This is when we're all kind of sitting around the whiteboard, sketching out a new application, a new API, and hopefully you've got security in the room, right? Make sure they're in the room. They're part of this discussion, right? And hopefully you're designing in security right up front. Okay, so once you've got that design, you're moving into development, right? So you're coding up your application and you're doing the things you normally do, right? Code reviews, static code testing, software composition analysis, and so forth, right? Those tools are going to look for pretty common basic vulnerabilities, right? Your code reviews hopefully will catch things like authorization flaws or logic flaws and so forth, right? But imagine that there's a logic issue that doesn't get caught here. Well, now you're moving into the next phase, which is testing or QA, right? And what are our approaches here, right? You've got your legacy dynamic testing tools, and then human or manual approaches, pen testing and red teams and bug bounties, right? But those automated tools don't do a great job of finding these complex vulnerabilities, right? So now that logic flaw has made it through, and now we're into deployment, right? We're running the API, it's live in production, and we're relying on the web server, the gateway, the WAF to be able to detect these things and prevent them and so forth. Okay. So what are the options for securing these APIs, right? And I'm not talking about like people in process, right? That goes without saying, but technical options. So you've got testing, right, which is a preventative, proactive approach, right? So hack yourself, find these vulnerabilities, simulate these different scenarios, and find the flaws before they can cause you any harm. And then you've got monitoring, right, which is reactive, right? Our APIs are live, they're in production, and we're going to try to put a video camera and detect these attacks as they are happening. Okay. So let's talk about the challenges of each of these. And thank you, Shelby, for flagging these questions. I'm going to do my best to get to them here in just a minute. So on the monitoring side, here's the problem, or here's the challenge that we've got with monitoring. And the challenge is API attacks look legitimate, right? And I'll give you two examples. The first one, you see here a GET request to user ID equals blank or 1 equals 1, right? I just learned this is like the most basic SQL injection there is, right? User ID equals blank or 1 equals 1. Well, 1 equals 1 for me, for you, for everybody. And if you're vulnerable to this injection attack, it's going to return your entire user database, right? But this is very obviously bad, right? And your WAF will for sure block it. It will see it, it will detect it, it will be able to identify it and block it. Nobody gets breached through this type of attack. And if you do, well, shame on you, right? There's lots of ways to prevent this. But look at the next example, right? User 10, and let's assume that they're properly authenticated. They got valid username and password. They're running a delete method on the transfers endpoint for transfer ID 123. Everything about this is legitimate. User's valid user, delete is a valid method, transfer is a valid endpoint, 123 is a valid transfer ID. Everything about this looks fine to your WAF. But imagine that this transfer doesn't belong to user 10, it belongs to user 11, right? Suddenly, this legitimate request isn't so legitimate, right? But there's no way your WAF is going to know, right? And this is the fundamental challenge that there is with monitoring-based approaches. You should do WAF, you should do all these things, right? But don't expect it to block every kind of API attack. And in fact, you've seen so many examples of breaches that made its way through the through the defenses. Okay, so then what's the challenge on the testing side? It's a different challenge, right? So we need to complement our monitoring with really effective testing, right? And here's what we need to think about from a testing perspective. At the lowest level, security testing, right? So like, do we have unsecured endpoints, right? Look at all those examples I gave you where the door was left unlocked, no authentication. Are we using incremental IDs like at Instagram that make it easy for harvesting or guessing at codes and so forth? Are we running injections and cross-site scripting and other types of scenarios? Then you've got data-oriented testing, right? So what kind of data is my API accessing? What kind of data is it returning? Is it too much? Is it appropriate? How is it controlled? Is there compliance implications for the data that's coming out of this system? And then you've got logic, right? So object ID manipulation, right? So like changing my Ethereum to Bitcoin, right? Cross account access, right? So accessing Joe Biden's Peloton records, or function abuse, like taking my free account, making it paid on Bumble, right? So these are probably the most difficult types of things to access, right? So what are the ways that people are using to test their APIs, right? And I'm kind of curious which one resonates with you, and if you agree with this. But option one is do nothing. Is actually quite common, and I wonder if anyone would dare to admit it. But this is very, very common, right? A lot of folks aren't doing much on their API. Remember that 4% API security testing that I showed you up front? This is clearly pretty common, right? Option two, do it yourself, right? By hand. Wolfram, yeah, I thought you'd chime in. Do it yourself. What do you, so I've seen a lot of chats like Burp, Zap, Postman, right? Fantastic technologies. They're incredibly popular, incredibly powerful, right? But here's the thing. You got to know what you're doing, right? So it requires a good level of sophistication. You got to know how to use the tool and what kinds of attacks to simulate on your API, right? And you have to have a lot of time, right? If your API's got 50 endpoints and you want to test each one 10, 20 different ways, that's 1,000 tests, right? You're just not going to get there. Andres, that's pretty funny. Option three, pay someone else to do it, right? Pen test or hire a red team or something like that, right? Pen tester, they come in once a year, they're going to beat on your API for a week, they'll give you a report, and then they'll come back a year from now, right? It's not continuous. It's kind of hit or miss depending on how good of a pen tester you hire, how well you arm them to test your API. Lumos, definitely the cheapest. I'm not sure it's the cheapest in the long run. But we want to come up with an option 4 here, which is automate, right? And before I get there, there are all kinds of automation tools. We just talked about some, right? Zap, Burp, Postman. We have released a tool I'm going to show you here in just a sec at APIsec. And I think what's special about what we do is it doesn't require a high level of sophistication or time, right? So if you want to get yourself a free Kasa voucher, here's how you can do it. And maybe Shelby, you can toss up the link here. But All you got to do with a tool like this is throw up or provide an API spec, whether it's in the form of a file or a URL that points to your specification if it's hosted online. And that's it. All right. The application will actually analyze that API, rip apart the documentation, and auto generate thousands of attack scenarios. Right. So you don't have to be an expert on this stuff. It will do it for you. And you can then even integrate it into your pipeline, into your Jira ticketing system, your gateways, and on and on and on. This is a brand new tool, and we'd love to get your feedback on it. So if you're willing to give it a test drive and then fill out a survey or spend some time with us, we will be incredibly grateful. We want your feedback. We want to make this as good as possible. And Shubham will send me an email. We'll make sure you get the survey link. You should automatically get it as part of the sign up process. But if you do that, fill out the form, do a really, give us some thoughtful feedback. We'll be happy to provide you with a Kasa exam as a thank you. All right. So that's our tool. As we wrap up here, real quick, some of the common findings that we hear a lot from doing these sessions. I've probably done 100 workshops this year. Over rotation on API discovery. Yes, you should discover every API. I've talked to so many security teams where they're like, this year we're going to do discovery and next year we're going to do mitigation, right? And that just seems sort of silly, right? Like if you know the front door is unlocked, right, go close it, right? You don't have to wait till you find all the doors in your building before you go lock the front door, right? If you're a SaaS vendor, a bank, a healthcare, your attackers are going to come to your homepage, your mobile apps. Those are the low-hanging fruit, right? So focus there, right? Like take care of the stuff that is right there in front of everybody. Incomplete, inconsistent documentation is still way too common, right? We got to make documentation mandatory, right? Don't allow APIs to go live without proper documentation. It can be automated. It could be hand-generated, you name it. Lack of standardized API processes. When I hear about shadow, rogue, zombie APIs, that just says you don't have standard processes, right? That's a governance problem. Shouldn't be random ways for people to stand up APIs in your environment. Relying on our SAST and DAST tools and thinking we're good, right? They're great tools, right? This is what's preventing us from getting breached through an injection or a cross-site scripting, but it's not going to find those logic flaws. I promise you that. Right. So don't think you're good because you're running a Nessus scan. Run the Nessus scan, but you got to go beyond it. And then relying on external pen tests once a year and thinking you're good. Well, you're probably not releasing code once a year. So we got to match the pace of our testing with the pace of our development team. So that's that. I want to invite you all to our webinar. It's happening a week from tomorrow. Thank you, Shelby. So we're going to talk more about API testing. We're going to do a live demo of the product. I've got my buddy Jose Peralta, who's a API security expert, author, and we're going to talk a lot about how to automate APIs, how to find vulnerabilities before they find them. Right. So please come join us next week. It should be a really exciting and interesting session. And as always, let me just let's leave that link up for just a sec. And then for everyone who'd like to get themselves a certificate for today, perfect timing, Mohammed. There it is. You can type that URL or we'll put it up here in just a moment. But just fill out the form and we'll be sending you a certificate of attendance and you'll get the Credly badge, all that nice stuff. So with that, I really appreciate you all making time here. I saw that we have a bunch of questions here. I got a few minutes. Let's see, from Stanley. What are the mandatory and optional list of things required in the documentation for APIs? That's a great question. I recommend you take our API security fundamentals course. I've got a module in there that talks all about documentation. Really, this is very, very standardized and well-known. Most common documentation is Open API specification or Swagger, you might hear it called. But you got to document what those endpoints are, what methods, what the payloads and parameters look like. Ideally include like sample values and any kind of permitted values and non-permitted values. Are you expecting an email or a string or a 8-digit character, or you want to define your authentication requirements and all this kind of stuff in your documentation. From Samuel, how often do you recommend pen testing? I recommend continuous, honestly. If you're releasing code every week, then your testing should be every week. If you're releasing code every day, then it should be every day, right? You can't hire a pen test firm every day, right? That's just not practical. It's not realistic. It's too expensive. And we're not saying don't do external pen testing, right? Bring those experts in periodically, but do automate your API testing, right? It should be. I mean, we're already automating testing for bugs, for performance, for functionality, for QA. There's no reason not to do that for security as well. The only reason not to do it is lack of tooling. And as you can see, there's some really great tools available now, right? And if you come join us next week, we'll go deeper into that. So it should be continuous. Honestly, there's no reason not to. How to find hidden APIs from Bilal? What tools can be used? This is probably the number one question we get: how to do discovery. There's no like easy button here, right? Discovery of APIs is really a multi-pronged effort, right? So you can do network discovery, so watching the traffic that's going along your network, right? If you're using F5 firewalls or Imperva, Cloudflare, these products do this, right? So go talk to your WAF vendor, right? They can discover APIs that you may not know about. They can even auto-generate spec files off that traffic, which you can then use to go feed into a testing tool, right? So network-based, you can do code-based scanning, right? So scan through your GitHub repos and find APIs. You can do crawling and spidering, right? You can do dictionary and just sort of search for APIs that exist in your network. And one of the things that gets overlooked is go talk to development, right? Security teams frequently say to me like, hey, I don't know what APIs we got, right? We don't have no idea, right? I've never talked to a VP of engineering that says, we don't know what APIs we got. Maybe they don't know 100%, but they sure know the majority, right? They're building them, they're running them, right? So we need security and development collaborating more, right? If you're saying we don't know, go talk to development, build that collaboration, that partnership, right? Because that needs to be there for APIs. From Danish, what kind of business logic flaw will you find in an internal assessment of API? So this is really a crucial question, right? You got to think about your business logic and not only how is it meant to work, but how could it be abused, right? So we saw an example at Instagram, right, of brute forcing a reset code, right? Authorization logic flaws are very common, right? We have a rule that says you have to authenticate, right? But once you're authenticated, can I access everybody's records, right? We need to look at the logic behind our authorization rules to make sure that users can't see or access data or functionality that doesn't belong to them, right? This is what we're talking about with OWASP number one, right? BOLA. It's number one for a reason. It has stayed number one. Biggest issue that we see with APIs. Are all APIs always easily found this way? Lumos, I'm not sure when you asked that question. Maybe that was when I was showing the United example up front. Yeah, it's quite easy to find APIs, right? And there's nothing wrong with that. That's how the internet works. A lot of people will say, well, can't I just encrypt the traffic and then it won't be visible? That's not true. That traffic is unencrypted when it's sitting inside my browser, right? It gets encrypted when it goes over the internet, right? So my browser has to be able to craft an unencrypted request to send to your server, right? And that traffic is easily visible. Hey, there's my dog. To you inside your browser, right? So that's fine. That's how the internet works. There's nothing wrong with that. But don't expect that your users can't see your API calls, because they can. No question about it. Okay. So that's our session here for today. I'm going to wrap up here. Really appreciate you all joining me again today. Please come join me a week from now or a week from tomorrow when we'll host Jose, and we're going to talk a lot about API testing. I hope you'll try out that new product and send me your feedback. Maybe even post about it if you like it on the internet, on LinkedIn, and share with your community. And certainly look forward to seeing a lot of Kasa exam certificates out there. So with that, thanks so much, and we'll see you next week.